Hi everyone, my name is Saurabh Pramanik. Today I'm creating some of the sessions on software testing as a topic, and we have different topics that we will getting covered. So this will be a series of sessions that I'm planning to start on software testing. I've been getting a lot of requests from people to upload doc videos and content on software testing. So here is it. So I will be starting today with some of the topics, and as we go ahead, so we'll be covering a lot of different other detailed topics on this. And definitely, I would like to know feedback and suggestions from your side, so that will help me improve. And I would request you to kindly like and subscribe to my channel as well as to the content that I keep on uploading. It keeps me motivated. Okay, so let's get started. So the topic that we'll be starting with is to introduce software testing. I have certain topics that we will be covering as part of this entire series. So we'll start today with understanding what is human errors and testing. And the whole purpose of this introductory chapter will be to familiarize yourself with some of the basic concepts that are related to software testing. Now, software testing is something that we keep on hearing a lot. But what exactly it is, there's a lot of, misconceptions, there's a lot of ambiguity in it. So this is something that we are trying to resolve as part of this entire series of sessions. Okay, so there would be some framework that I'm going to discuss that will basically help you to, as we move ahead, to understand your different concepts on these different topics. First and foremost, let's start with what is human errors and what are testing is part of it. Now, errors, as you know, are part of our daily life. Now, as humans, we will keep on making errors. There is a lot of errors we do with respect to our thoughts that we have, with respect to some of the actions that we have, and as a part of it, it also goes ahead in some of the actions that it happens, right? So errors occurs almost everywhere. Now, humans make errors in some with their speech, with while let's say you're visiting a doctor, the doctor is prescribing some medicines, there could be some level of error. There could be some fragment of error with respect to surgeries when you're driving a car, or let's say, for example, when you're observing. A lot of times you also make some errors, right? At the same time, there could be errors when sports person do. There would be you're doing some software development, and those kind of areas also, errors would be there. So there would be different types of errors which could be there. Now, this table will look into it, which basically categorizes these different errors. And one of the very important aspect is with respect to the consequences that happens. Now, the consequences of human errors, it will vary significantly. Right now, an error might be insignificant. It will basically lead to a kind of a sometimes it might be, the errors might be also sometimes good also, like, for example, if a person is has said something by a slip of the tongue, and then you everyone starts laughing, right? So there should be some other things also that might be happening. Now, these are some of the examples. If you see, like, for example, when it comes to hearing, so it could be also with respect to when someone has spoken, right? There has been a garage for repairing foreign cars, and what you might have heard is he has a garage for repairing falling cars instead of foreign cars, right? So it's a big, it might hear a bit kind of humorous, but yeah, that is definitely an error. Then definitely from medicine perspective, there is an incorrect antibiotic that might be prescribed. From musical performance perspective, there might be a note, like some of you might be musical players, so you know how important, how accurate each of the notes and the sequence of the notes has to be, right? So an incorrect note when it plays is basically impacts the entire performance. Similarly, there could be errors with respect to the incorrect algorithms that might be there. In case you are making some incorrect inversions or matrix formulas, some matrix inversions that you're doing, that could be incorrect, right? Similarly, from an observations perspective, the operator is failing to recognize that relief valve might be stuck open, or there might be some action that was required which was not done. From a software development perspective, each and every one of us understand, how errors basically can impact the behavior of that entire application or that entire algorithm, right? And there are so many different small, it could be a small error, but then it could basically lead to a majority, release also, because it might impact the entire final output that it might be impacting, right? Similarly, from a speech perspective, the way it has been spoken, it might sound something different, and it might mean something different. From a sports perspective, there might be, let's say, the referee is making a wrong decision based on the error that the referee is making, right? So those are also chances wherein error could be there. Similarly, from writing perspective, you wanted to write something else and then you're writing something else. So that could be another, a very typical case wherein there could be an error. Now, to determine whether there are any errors in whenever we say in our thoughts with respect to our actions and the products which are generated, we normally, what we try to do is we try to resort to a process which is the testing process, right? Now, the primary goal of the testing process is to determine if these thoughts, the actions, the products which are as desired as it is, and they are basically conforming to the requirements. Now, testing of thoughts as is usually designed to determine if the concept or the method has been understood satisfactorily. And testing of actions is also designed to check if the skill that is resulting in the actions has been acquired satisfactorily. Okay. Now, testing of a product is normally designed to check if the product is behaving as desired. Okay. And, if it is also to verify, whether there is any syntax or there is any semantic errors also to that might basically arise during the programming, right? So most of the modern compilers are able to detect the syntactic errors. They are able to testing the focus on the semantic errors. There are some faults that might happen and that can cause the entire program under test to behave in an incorrect manner, right? So those are different things. Now there could be several types of examples that could be thought of. Like, for example, an instructor is administering a test, and this instructor wants to determine how well the students have understood what the instructor wants to convey. Okay, right? For example, there could be a tennis coach who is trying to tell or administer a kind of a test that basically this tennis coach is basically trying to understand how well the understudy is making, how the serves are being made, the tennis players are making the serves, right? Similarly, software developer might test the program to determine if it is behaving as per the required behavior it has, right? Now, each of these different cases that could be there would be definitely an attempt by the testing person who is testing to determine if there are the thoughts, what are the thoughts of the human, what are the actions, what are the behavior of that human being has happening that might be causing an error, right? Similarly, when we say deviation from the expected as a term, you might be hearing this term deviation from expected, right? Now, this may not be due to any kind of an error, because or one or more reasons, right? So supposedly a person who is testing, this person wants to test the program and they want to find out a sequence of integers. Okay? Now, the program that has been written can basically try to sort this input sequence in an ascending order or a descending order based on whatever the request has been made. Right? Now, supposedly this testing person who is testing wants to check if this program is sorting the input sequence in an ascending order, right? So to do so, what this person might be doing is she might be trying to is trying to type in a specific input sequence and that placing that request to sort the sequence in a specific descending order, right? Now the program is correct. Now the program doesn't, let's say supposedly let's assume that the program is correct and it's producing an output, right? Whereas when the input is required in the descending order. But when you're examining the output of the program, right? So there are some hypotheses which the testing person will try to do. That will basically try to say whether the sorting program is correct or incorrect. Right, so this is normally a situation which will, whether the tester is making a mistake, and that is basically leading to any kind of an incorrect interpretation. That is what the testing person will try to do. Okay. Now, when it comes to error, faults, and failures, there is a very important aspect when it comes to the understanding the errors, faults, and the failures, right? So there is no widely accepted and precise definition that we have of the term error, right? So if you look at this diagram, it will basically try to illustrate one of the meanings for the terms, like when it comes to error, fault, and failure. Like when a programmer is writing a program, right? An error normally occurs in the process of writing a program, right? So that could be there. Now, a fault is basically a manifestation of one or more of these errors, right? A failure is normally occurring when a faulty piece of code is being executed, leading to an incorrect state that is propagating to the program output. Now, the programmer might misinterpret the requirements and consequently will try to write incorrect code, right? Upon execution of this, the program might display behavior that does not match with the expected behavior, implying that a failure has occurred. Okay. Now, a fault in a program is also commonly referred to as bug or a defect. Okay. Now, the terms error and bug are by far the most common ways how we try to refer to something which is wrong in the program, right? And that might be causing or leading to a failure, right? We often use some of the terms like error and fault, and they could be used as synonyms. Okay. Now, faults are also sometimes referred to as defects, right? Now, if you look at this figure, notice that the separation of the observable form from observed behavior. Okay, that is something, this kind of a separation is very important because it is the observed behavior that might lead to conclude that the program has failed. Okay, now certainly, as we have explained earlier, this conclusion might be incorrect due to one or more of the reasons that could be there. Okay, now when it comes to another important aspect, which is also called as test automation. Okay. Now, test automation is what whenever we want to test complex systems embedded and any other similar kind of programs, a human intensive task which might getting iterative, right? So a human might need to execute thousands of these tests to ensure that the change that has been made to the component of the application is not basically causing the previous correct code to malfunction. There could be also execution of many tests that might be tiring as well as that could be error prone. Okay, hence there is a tremendous need for automating these testing tasks. Okay, now most of the software development organizations will try to automate the test related tasks using processes like regression testing, GUI testing, input output device driver testing. Okay, but unfortunately the process of test automation cannot be generalized, right? For example, automating regression tests for an embedded device such as a pacemaker is quite different from that of an IO devices. Like for example, that is basically connecting to a USB port to a that is getting connected to a USB port. Okay. Now, such lack of generalization often will lead to specialization or specialized test automation tools, right? Nevertheless, there also exist general purpose tools for test automations. Like for example, you have such tools which might not be applicable in all test environments. They're useful in many, right? So some of these tools like Eggplant, Marathon, Pounder, there are multiple testing tools that are being used like for GUI testing. There could be testing tools like Load Runner, you might have heard of DB Monster, JMeter, that could be used for performance or load testing purpose. Similarly, you can have Echelon, you can have TestCube, WinRunner, Xtest. They are used for regression testing, quite popular there, right? Now, despite the existence of this large number and variety of test automation tools, large software development organizations will try to develop their own test automation tools, primarily due to the unique nature of the test requirements, right? Like for example, you can have an automated test generator that could be used to variety of applications for doing combinational design techniques, right? So you can do random testing for estimation of reliability of products, right? There could be, you might try to test an application using random generated tests so that you want to determine how frequently does the software might crash or it might get into a hung state, right? So those could be there. So there are different tools that could be used. So test automation is also one of the very reliable and faster completion method how you can basically automate some of your routine tasks, right? So that is there. Now when it comes to Another important aspect is of software quality. But before we go to software quality, we have developer and tester. These are some of the common roles that you will keep on hearing when it comes, right? So developer, as you know, is someone who is writing the code, and tester is someone who is trying to test this code, right? So normally we prefer to treat the developer and tester as two distinct, but these are kind of complementary roles, right? The same individual could be a developer and a tester, right? It is very hard to imagine that an individual who is trying to assume the role of a developer will not be never in his life be a tester, or vice versa, because you will see that the developer also trying to do some kind of unit testing for his code, right? So that same person might be changing hats and be playing the role or different kind of a role. Now, in fact, it would be safe to assume that the developer is assuming two roles, that of a developer and of a tester, but at different times, right? Similarly, the tester might also assume two different roles, yeah, but at different times. Sometimes the tester might also go into in developing some of the testing scripts, and has to develop some of these test automation scripts and those kind of things. So that tester then starts becoming like a developer, right? So within a software development organization, the primary role of the individual might be to test, right? Hence, this individual assumes the role of the tester. Similarly, the primary role of an individual who is trying to design the applications and writing the code is that becomes a developer. A reference to tester, we will try to see again and again what is the tester. Similarly, you will also hear a term which I will keep on, bringing again, which is a more of a programmer, right? So a programmer is trying to refer to an individual who basically engages in a software development process and will often assume the role of the tester temporarily, right? And it also will try to become a developer kind of role. So interchangeably, we'll also try to use this role immediately also.
The next thing that we're gonna study is on software quality. We all want high quality software, right? Now, there might be existing several different definitions of a software quality, but one of the quality attribute which would be more important to a user, right, might be varying, right? So that might not be very much useful for this area. So there are different quality when we define quality, right? It has to be associated with some attribute. It can't be said that the quality of this product is not good, the quality of the software is not good. So you'll have to associate it against, like for example, you say when we say the quality, so the data is not coming as complete, the data is not coming as accurately, and also you will have to provide a measure. You will have to quantify what is right. So you will have to measure. You will have to provide some dimensions with respect to the quality, right? So there could be different types of quality attributes that exist, right? So we will primarily divide them into two main components or main categories. One is the static and the dynamic quality attributes. Now, static quality attributes will try to refer to those of the actual code and the related documentation because they are static in nature. Now, dynamic quality attributes will try to relate to the behavior of the application while it is being used. Okay. Now, static quality attributes, they will include structured, maintainable, testable code as well as availability of correct and complete documentation, right? You might have to come across some of the complaints. Let's say, for example, when we say product X is excellent, right? I would like the features it offers, and it also the user manual. It basically is something that is not really happening for me, right? So the user manual is trying to bring the overall product quality down, right? So from even though we mentioned that it might be good product, but the user manual is something that is affecting the overall quality. Now, let's say, for example, if we are kind into a, like, if you are playing the role of a maintenance engineer, and let's say you have been assigned the task of doing some of the corrective maintenance of the application code, then you will most likely need to also understand some of the portions of the code before you want to make any changes to it, right? Now, this is the place where the attributes such as the code documentation, understandability, structure might come into play, right? Now, there could be a poor documented piece of code which might be harder to understand, and we might because it is harder to understand it, but might also be very difficult to modify that, right? Now, poor structured code might be harder to modify and also it might be difficult to test. Now, and another aspect to it is the dynamic data quality attributes. Now, when dynamic quality attributes comes into place, it also includes some aspects with respect to the software reliability, the correctness, completeness, consistency, usability aspect, and the performance aspect. Now, reliability also refers to the probability of failure-free operation, right? And is also being considered as when we say as a very important aspect. Similarly, correctness is also refers to the correct operation of that application and is always the reference to some of these artifacts. From a tester, when we say correctness is always with respect to the requirements, right? For whether the requirements have been provided, as it is also with respect to reference some of the documentations like user manuals as well, right? Similarly, completeness refers to the availability of all the features that has been listed in the requirements or which is being provided in the user manual, right? So, and incomplete software is one that is not being fully implemented, right? It doesn't have all the features that have been mentioned and they have been available, right? So when one is trying to encounter some additional functionality which might be required of which each of the versions. So it does not mean that a given version is incomplete because the next version might be having some of the other features, right? So completeness is defined with respect to a set of features that might itself be like a subset of a larger set of features that have to be implemented in some future version of the application, right? Now, one can easily argue, right, that every piece of the software that is correct is also complete with respect to some of the feature sets. Okay, consistency is another aspect which defines your software quality. Now, consistency refers to the adherence to a some common set of conventions and assumptions. Okay, now that is a very important aspect, right? For example, all the buttons in the user interface that you might have, right? They might try to follow kind of a common color coding, right? And also an example of inconsistency would be like, for example, there a database application, right, that is trying to display the date of birth of a person in the database. However, the date of birth is displayed in some different formats, so it is not consistently being shown, right? As some of the formats might be, some of the data might be in DDMM YYY format. Some of the data might be in, your December or in January. The entire month might be. So it is not being consistently shown, right? So consistently basically will say that how the data needs to be shown. Similarly, another important attribute is with respect to the usability aspect. Now, usability will normally refer to the ease with which the application can be used, right? So this is an area in itself where, example, how usable the entire code is. So whether it's usable or whether it's not usable. And psychology kind of plays a very important role when we try to, in with respect to the design of techniques that could be used for usability testing. Now, usability testing also will try to refer to the testing of the product by the potential users. The development organization tries to invite a kind of a set of potential users and they will try to ask them to test the product, right? So, because from a user perspective, the psychology of the user has to be understood, right? So, what these users will gonna try to do is they will try to test, these products with respect to the ease of use, with respect to the functionality as expected, with respect to performance, with respect to safety, with respect to security, right? So the users therefore will serve as a very important source of the test that the developers or the testers within the organization will try to do. Now, usability testing is also sometimes referred to as user-centric testing. The other aspect, another type of testing that we have is the performance testing. The performance which refers, or the performance aspect of software quality refers to the time the application takes to perform a specific requested task. The performance is considered as a non-functional requirement, right? It is not as a functional requirement, but it is also defined in respect to terms like, let's say, for when we say this task must be performed at this rate, there is X units of activity in 1 second on a machine needs to be uh, working and at a specific speed, right? And what we are trying to do, we are defining the performance aspect, the performance parameter, right? So there could be another example is the performance requirement for the compiler might be stated with respect to the minimum average time that might be required for compiling the application, right? So the processing aspect of it. So that is also what performance tries to define. Now, the other aspects is with respect to some of the uh, components that are very much important. Now, another important parameter that we want to know or we want to discuss is with respect to the reliability aspect, right? So now reliability is something that is also very much important because reliability speaks about how much we can basically understand and rely on that underlying software or the data, right? So reliability is considered more of a statistical measure of correctness, and we want to understand whether this is something that is more reliable, right? So this is something that we will. So software reliability is basically what is the probability of failure free operation of the software, as you can say, right? This definition that I was mentioning with respect to reliability is independent of who is using what features of the software or how often it's being used. Now it depends exclusively on the correctness of the features. Now there is no option of operational profile. The entire input domain is considered as uniformly distributed. Now the term environment, whenever I said, right, it will try to refer to the software and the hardware elements that might be needed to execute the application. These elements will also include the operating system, the hardware requirements, or any of the other applications that might be needed for communication. Now, both these definitions have their pros and cons. Now, first of these two definitions will try to require the knowledge of the user profile of the users, which might be difficult or impossible to estimate, right? However, if there is an operational profile can be estimated for a given class of users, then there could be an accurate estimate of the reliability that could be found for the specific class of users. Now, the second definition that we have, which we learned about reliability, which is more about the failure-free operation, is something that we basically also gives a lot of clarity with respect to how you are able to measure the estimate that you might be coming up or arriving at. Okay. Another aspects is with respect to the requirements, behavior, and correctness aspect, right? With respect to the products and the software in particular. Now, these are designed to with respect to the requirements, right? In response to some of the requirements that have been provided. Now, requirements will normally try to specify the functions that the product is expected to perform. Now, once the product is ready, it is normally the requirements that will try to determine the expected behavior, right? Of course, during the development of the product, the requirements might have been changed, or whatever has been previously been said as per the original requirements, there might be cases that might get changed. Now, regardless of any change, the expected behavior of the product is determined normally by the tester's understanding of the requirements that they have been identified or they have understood during testing. Now, let's say, for example, there are two requirements, which is leading to a different kind of a program. So, for example, there is a requirement one. It is required to write a program that tries to input two integers and output the maximum of these integers. And similarly, there is a requirement two, which is required to write a program that inputs a sequence of integers and outputs the sorted version of the sequence. Right? So there are two different. Now, supposedly there is a program max, which is being developed to satisfy the requirements one. Okay. Now, the expected output of this max could be, let's say, for example, there are whenever the input integers are coming, let's say we take two integers, 13 and 9, right? So, can we determine what is the maximum of these integers? So, obviously, out of 13 and 19, 19 is something which is a higher number. Now, supposedly, the tester wants to know if these two integers are to be input to the program on one line, followed by kind of a return that might be getting, or so you want to write them into two separate lines, and that can basically provide a return after each of the numbers, right? So, this requirement that has been provided is not will not be able to answer this question and will try to fail to provide the answer that could be which is more detailed with respect to this question. Right now another requirement, if you see the second requirement, is very much ambiguous, right? It is not very clear from this requirement whether the input sequence that has to be sorted in an ascending or a descending order, right? So the behavior of the sort program that is written to satisfy this requirement will definitely will depend on the decision that has been taken by the programmer while writing the sort. So you mentioned whether you want to sort ascending or descending. You will have to make some assumptions on that, right? So it is not complete or it is an ambiguous kind of requirement. And in real life, you will see that testers will a lot of time will trying to face this kind of an incomplete or ambiguous requirements. Or and so what happens in such kind of situations? So in such kind of situations, a tester might try to resort to a variety of different ways to determine what behavior to expect from the group, right? So for example, there could be above program max. One way how we can determine how the input should be typed is to firstly actually examine the program text, right? So harder way could be, you might have to try to ask developer what is of max and what is the decision that was taken regarding the sequence in which the inputs have to be timed in. Or there could be another method that could be like, for example, to execute the max on different input sequences, right? And then to determine what is acceptable to max. Now, regardless of the nature of the requirements, normally testing will require the determination of the expected behavior of the program under test. Now, the observed behavior of the program is normally compared with the expected behavior to determine if the program functions are desired. Another aspect is with respect to the completeness or the incompleteness of the requirements. Now, after seeing or looking after the completeness, incompleteness, or the ambiguity part of the requirement, the another aspect is with respect to the input domain, right? Now, normally a program is considered correct if it tries to behave as desired, on all the possible text inputs. Usually, the set of all the possible inputs is too large for the program to be executed on each of the input. Now, for example, supposedly the max program is being provided that is being tested on a computer, and there's an integers range that has been provided. Huh? Now, to test the maximum all the possible integers will require this entire program to be executed on different pairs of integers, right? And it will also require like a total number of kind of an executions, right? And there would be a specific period of time that would be taken. Let's say, for example, approximately it's taking 4.3 seconds to complete all the executions, right? So, because of which, there, on an average speed, what is the average execution time that is being taken, right? Now, whenever you're testing a program on all of these possible inputs, this is what you also call it as exhaustive testing, right? But the reason we are saying it as exhaustive testing because we are trying to exhaustively test it on all the different types of inputs, right? Now, normally a tester will often try to need to determine what is basically constituting all of these possible inputs. And the first step in determining all these possible inputs is to examine the requirements. If these requirements are complete and unambiguous, then it should be possible to determine the set of all these possible inputs. Right? Now, a definition is in the order before we provide an example. Let's say how we can determine the set of all these program inputs. So we will try to see different types as an example. So let's say, for example, in requirement one previously that we had, we try to provide an input domain of maximum to, the set of pairs of integers where each element needs to be present in a specific range between minus 3 to 30,768 to 32 positive 32,767. Right, so we want to find the input domain of max to be the set of all pairs of integers. Uh, and similarly, let's say from the requirement two, uh, we it's not possible to find what is the input domain for the sort program because of the ambiguity that. So what we'll try to do is we'll try to modify this requirements a bit. Like, for example, the requirement two will try to say that it is required to write a program that inputs a sequence of integers and outputs these integers in a specific sequence sorted in either ascending or descending order. So now we are trying to specify this order in which it needs to be sorted. The order of the output sequence is normally determined by the input request that is being associated. Okay. And it basically should be A when there is an ascending sequence is desired, and it should be D when there is a descending, right? Now, while providing the input to the program, the request character is entered first, followed by the sequence of integers that needs to be sorted. The sequence is terminated with a specific period. Now, based on the above modified requirement, the input domain for the sort is a set of pairs. Now, the first element of the pair would be a character. Okay. And the second element of the pair is kind of a sequence of zero or more integers ending with a specific period. Okay. Now, for example, there might be three different elements in the input set, and there could be there could be a possibility with respect to the kind of values that is associated. Now, for example, there are three elements in the input domain that we have. Let's, for example, A minus 3, 15, 12, 55, right? This is first. Then we have D, this is descending, 23, 78, right? And then we also have A. Okay. Now the first element is containing a sequence of four integers, right? That we want to sort it into a specific ascending order. The second element is a sequence that needs to be sequenced in a descending order. So this D is mentioning that it needs to be sorted in a descending order. And there is a third element which is more of an empty sequence. It doesn't have anything and it needs to be sorted into an ascending order. Right? Now we are basically ready to give the definition with respect to the correctness. Right? So when we say correctness, a program is normally considered correct it which tries to behave as expected on each of these elements of the input domain that we have. Okay. Now, how do basically we specify the program behavior that we have? Okay. Now, when we try to mention, we also will have to mention what is the kind of the behavior that we might be having with respect to the program, right? So that is very much important because we need to specify what is the behavior that is gonna be present with respect to the behavior that is we gonna have with respect to the data, right? So the aspect that defines this is we will have to understand with respect to what are the kind of the inputs that is coming in, right? So the aspect is with respect to the what is valid input and invalid input, right? Now the input domains that has been derived from the normally with the requirements. However, due to the incompleteness of the requirements, one might have to think a little with respect to how you define what is the input domain, right? So let's say, for example, we have a modified requirement, right? Now the requirement mentions that the request characters could be in ascending order or it could be in descending order, right? But it will try to fail to answer one of the questions. Like, for example, what if the user is trying to define or specify a different character other than A or D, right? So when we are trying to using sort, it is certainly possible for the user to normally type a character other than which is A or D, right? Which is standing for ascending or descending. So any character other than ascending or descending is normally considered or should be considered more of an invalid kind of an input to sort. Right? Now, the requirement for sorting normally will not specify what the action it should take when that input invalid or input is being. Identify the set of invalid inputs and testing the program against these inputs is a very important part of the testing activity. Even when these requirements are failing to specify the program behavior on the invalid inputs, the programmer should not basically try to treat these in one way or the other, right? So testing a program against some of the invalid inputs might reveal some of the errors which might be associated with the program. Right. So, let's say, for example, we are testing a sorting program. Right now, we execute it against a specific inputs. Like, so for example, the input just earlier we saw A and D. Now we are getting a alphabet E, right? 719, and then we try to have a end. Now, the requirements that has been mentioned in this are insufficient because we cannot determine what is the expected behavior of sort because now we are able to see that there is an E. Now, supposedly, upon execution on this input that we are getting, the sort program enters into a more of a infinite because there is no error handling that has been done. It moves into an infinite loop because it has been not been provided a specific, kind of a decision on the execution what it needs to do. So it basically neither asks the user for any of the input nor it basically responds to any time which has been typed by the user. Now this observed behavior points to a possible error process that could be available in the sorting process. Now, the argument above can be extended to apply to the sequence of integers that needs to be sorted. Now, the requirements for the sort program normally will not specify how the program should behave. If instead of typing an integer, the user is typing a specific character, let's say, for example, a question mark here. Right? So, of course, one would say that the program should normally inform the user that the input is invalid. But this expected behavior from sorting needs to be tested again, right? So this also has to be considered when you're trying to, try to test. It basically should define or suggest that the input domain should be modified, right? Similarly, for example, there could be another example, right? So let's say, for example, we are considering a sort which is trying to get valid and invalid inputs, right? Now, the input domain that has been derived in example, previous example, that needs to be provided or modified, right? Now, this modified input domain consists of different pairs of values. Now, the first value in this pair is, let's say, an ASCII character that can be typed by the user as a request character. And the second element of the pair is more of a sequence of integers that are interspersed with some invalid characters. There is defined by the period, right? So, when we say, let's say, for example, we have an output something which is similar to this. You have A, you have 719, and then you have this, and then you also have D, right? So now we can see now the only problem in this example, you can see that along with the numbers, we are also getting a specific kind of uh, that is 9f, right? So how we here we assume that there is an invalid character that has been that has been provided as an input to the sort program. Right. Now, this might or not be like a situation in all, every time we might have, but this is possibly a situation that might happen. Right. So, how the program needs to understand these inputs, right? The correctness of the inputs that should be right? The how the invalid inputs that is coming in, right? So how the tester should also be able to test how the program is working for these kind of, right? So uh, that will basically make the program more robust with respect to the different types of inputs and the kind of scenarios that it would be, the way the scenarios how it needs to be will be handled, and it would be try to act based on those scenarios. So that is another aspect that needs to be taken. The next area that we will learn is with respect to correctness and reliability, right? So firstly, let's try to understand what is correctness, right? Now, program correctness normally is being established using some mathematical proofs, but program reliability is normally being established with respect to testing, right? So neither of these approaches is foolproof, but we'll try to understand what is correctness and what is reliability and then we'll spend some time. So let's start with correctness. So though the correctness of the program is normally desirable, it is almost never that is the entire objective that we want to do for testing for. So whenever we want to establish correctness by testing, we will basically imply testing a program on all the different elements in the input domain. In most of the cases, there would be encountered, it might be very impossible to accomplish that, right? So correctness is normally established via mathematical proofs of programs that would be there. And a proof is normally provide, will try to provide a specific formal specification of the requirements, and the program is texting or trying to prove or disapprove that the program will behave as has been intended to behave, right? Or it will work as has been intended to work, right? There could be a mathematical proof that would be more precise, right? But it might be also subjected to human errors, right? So whenever the proof is being carried out by the computer, the simplification of the requirement specification and the errors that are there in the task, they are not fully automated, might also render the proof as useless, right? So while correctness is trying to attempt to establish that the program is error-free, there would be testing attempts that might try to find if there are some errors in it. Now, completeness of testing does not necessarily demonstrate that the program is error-free. However, as the testing progresses, errors might be revealed. There would be removal of errors from the program, usually, which might also improve the chances or the probability of the program executing without any kind of failure. Also, there would be a testing, debugging, and the error removal process together will try to increase the confidence in the correct functioning of the program under test. Right now, there could be there could be an scenario like, for example, let's take an example that can basically understand or illustrate by the probability of program failure might not change upon the error removal, right? So consider, let's say we have a small program and then we try to, as part of the program, we try to input two integers x and y and we'll try to print the value. So let's say, for example, we write a small program integer x comma y. We have input x comma y. Now, if x is less than y, then print x, else print y. Okay. Now, what happens is this program, if you see, it will try to use two functions, right? Now, these two functions is basically the print functions, how you want to think. So let's say, for example, we write it as f of x comma y, right? And this function we say like a g of x comma y. So we are not defining these functions here, right? But we are saying that you output, right? This as x as f or y, right? So where exactly it will get invoked or how the program is working, whether the program might fail, right? So when in this current form, if you see, since we don't have a definition of f of x comma y and g of x comma y, the program will fail when we are trying to uh, test it against the input values because the function that has been provided, that is f of f and g, they are not specifically mentioned. Now, let's say, for example, if you're trying to remove this error, you're trying to make this uh, fail, right? So how you're basically correcting, right? So that is very much important. That basically tells you the correctness of the program that you're trying to do, right? So you can have some mathematical proofs or formulas that can basically help you in understanding the correctness of the program, right? Whereas when it comes to reliability, the probability of the program failure is captured more formally with respect to the reliability, right? Now consider let's say we also understand the reliability as a definition. Let's say, so the reliability of a program, you can just think is the probability of the successful execution on the randomly selected element of the inputs domain, right? So this is something as a more of a definition or formal definition that has been provided. So normally reliability, you also consider it as more of a statistical attribute, right? It is the probability of failure-free execution of a program against specific different conditions, and there are different ways how the reliability could be defined, right? So a comparison of the program correctness and reliability normally will reveal that while correctness is a more of a binary kind of a metric, reliability is more of a continuous kind of a metric over a scale that we consider from 0 to 1. Right? Now, a program can be either correct or incorrect. Its reliability can be anywhere between 0 or 1. So, intuitively, what happens whenever there is an error that is being removed from the program, the reliability of the program that has been obtained is expected to be higher than that, that basically contains the error. Right? So, that is another thing. Now, let's take a small example. So, for example, let's say we have a small program P that basically is trying to consider or take a pair of integers as inputs, and the input domain of the program. will be the set of all the pairs of these integers. Now, supposedly, in actual use, there are only three pairs that have been provided an input to P. Let's say, for example, we have inputs as 0, comma 0, minus 1, comma 1, 1, comma minus 1. Okay, these are the different pairs of inputs that we try to consider as part of. Now, these three above set of pairs of, which is there, is more of a subset of the input domain of P and is normally derived from a knowledge of the actual use of P. It is not solely from the requirements that will be there. So supposedly there is also each pair which is equally likely to occur, right? It is if it is known that P is failing on exactly one of these three possible inputs, then normally the frequency with which P will function correctly is gonna be there. Then let's say only one is exactly failing, then we know that out of three, so the probability of correctness will be like almost like 2 by 3 because one of them scenario is failing. So 2 by 3 would be the probability at which we will say that the function is correctly functioning. So that is the statistical measure, how you're trying to measure the reliability of a program. Right? That is another aspect. Now, another aspect we will have to also understand is what is the operational profile, right? Now, as per the definition, if you see the reliability of the program will also depend on how it is being used, right? So, for example, in my previous example, when I said that these, is not, let's say, executed on a specific pair. Let's say we take this first pair. On this pair, we are not trying to execute, right? Then it basically restricts this input domains. And we know that now the domain gets restricted not to this, but these, right? So the reliability of P is there because we have already excluded this. So now reliability of this pose increases because we are trying to have remove the errors that are there, right? So the operational profile basically is a statistical measure that is basically telling you how the program would be used actually in practice, right? So operational profile is also a numerical description of how the program is being used. And normally in accordance with the definition that you have, the program might have several operational profiles depending on the users. Okay, so for example, consider there is a sorting program that we have, and on any given execution, there is one of the two types of input sequence that is available, right? Now, one sequence, if you see, is consisting only of numbers, and the other is consisting only of alphanumeric sequence. So, one operational profile for sort is being specified something like the numbers only plus a probability of 0.9 and alphanumeric strings with a probability of 0.1. And there could be another operational profile for sorting that could be, set like where operating numbers only will be like having a probability of 0.1 when alphanumeric strings having a probability of. Now, these two operational profiles will try to suggest significant different types of uses of sort. In one case, it is used mostly for sorting sequences of numbers, and the other case, it is mostly used for sorting the alphanumeric sequence. The next area that we're going to learn is with respect to testing and debugging, right? So normally testing is the process of determining whether the program is trying to behave as it has been expected to behave, right? Now in this process, one may try to discover there are errors in the program which might be there, right? Now, however, whenever testing reveals an error, the process used to determine the cause of this error and to remove is also known as debugging of the entire uh, you know entire process. So there are different steps that have been involved as part of this, right? The first and foremost aspect here is to how do you basically prepare a test plan, right? So preparing a test plan is the first and important step, wherein so what you do as part of preparing a test plan, you are basically trying to, as part of preparing the test plan, what you're trying to do is you will try to uh, you know, have a plan in place, right? There could be small programs that could be being tested, and normally a test plan is the informal way how you'll try to have the entire you plan out your activities, right? So how you basically try to have a specific what is the process, what are the steps that you're gonna consider or you're gonna take. Like for example, what is the entire input the cycle as part of the cycle, what are the entire steps that would be considered as part of this, right? So you'll try to create a plan that will basically help you in understanding the entire process, right? Now, as part of this plan, there could be different scenarios or different steps that would be there. So one thing is with respect to the test data, right? So you also need to understand and have what is also called it as the test data. The test case is a pair of input data and whatever the corresponding program output that would be associated to the test case. So this test data, this set of values that will be provided to this test cases, right? So for each of this set of values for one of the input variable, a test set is a collection. These test sets cases will form part of a test set, right? So it is a collection of different test cases that would be uh, doing with respect to one of specific pair of input data, what would be the program output that is expected, right? This test set is sometimes also called it as test suite, right? So there are different ways how they could be called as. You can also call it as test suite, right? So these are also called as test suite, and Notion is one execution of the program is sometimes tricky, but test data is an alternate term that you can also consider with respect to test. Now, program requirements and the test plan normally will help in the construction of the test data. Now, whenever you try to do the execution of the program, on the test data might begin, after all, with respect to few cases that have been constructed. Now, while you're trying to test there could be relatively small program tests because where would be few test cases that would be executed and there would be program that would be run against these test cases, right? So there could be different type of test cases that could be written and the test plan basically will die. So if you see this basically diagram is trying to create the entire cycle with respect to a testing and a debugging, right? So if you look at this it basically tells you what is the steps. So it normally starts with the input domain, the where the input data needs to be set up. Then you try to construct the test input. You try to use the operational profile and the test plan, and then you try to execute the program as part of the test cases. You'll try to see the behavior. What is the kind of behavior that you have? Is the behavior expected as expected as it is, or if it is no? Then what happens? So if it is expected, then you try to terminate the testing and then you can also mention what is the report. You do the reporting. But supposedly the expected is not as expected. So what is the cause of the error, right? So we'll try to diagnose and go deep into it respect to understanding what is the cause of the error. You then try to also debug the program, right? So you try to debug the program, you then write them as part of the testing plan and then reiterate the process, right? And then in you try to see whether the error is fixed and you try to uh, fix the error, you try to send the error reporting as part of the operational profile. So this is more of a cycle that, and you can see that there is a feedback that goes back, right? So if the testing is not terminated, so it keeps on going ahead as part of the regression unless and until the entire entire program of the code is error free and is now could be certified that it is being available without any kind of error. Now, when it comes to test plan, so this test cycle that is being provided or you will see is normally being available as part or is being guided by the test plan, right? So it basically tells you like let's say for example there is this program which is there and you want to this sort program that you have, right? So you want to test this sort program to see the requirements that have been mentioned. So first there could be different steps that would be included as part. So first and foremost, let's say you will try to execute the program on at least two input sequences. Like so, for example, one with an ascending order and one with a descending order has some of the specific characters that have been available. Next thing that you'll do is you'll try to execute the program on an input sequences, empty input sequence, right? That could be another test case, right? Then you can also do is you'll try to test the program with respect to robustness. You know, if there is any erroneous inputs coming in, like R other than E and D, then in those cases, what happens? And all the failures of the test programs which are there, they should be definitely, recorded in a specific suitable file which might be there, but that would be coming, right? So what is the behavior of that in this? So normally the test cases that we will have as derived as a response to the different items that will be there. So that will be tagged against the test cases. And we normally have designed two test cases in response to the items, but also the requirements of the sort program that will be there, right? So it will also try to indicate what should be the output of the sorting, right? Is there anything that needs to be sorted, or is it something like an expected output, or what is the exact behavior? So normally the test set is basically the collection of zero or more of these test cases. Okay. So program behavior is basically gonna tell you how is the program, gonna behave, right? So how is the program is gonna behave can be told or can be explained with respect to, it can be specified with respect to different ways. Like for example, it could be mentioned with respect to a simple language, natural language, or you can also specify with respect to a state diagram. You can also mention with respect to some mathematical specifications, right? Now, when it comes to state diagram, a state diagram is trying to specify or state the what is the program state and how the program is going to change with respect to anything of the different input sequences or the different inputs that is coming in. Right? That is there.